we are going to first pick positive value for p, and then we are going to work out this limit. This is the limit when x is approaching to infinity. We have ln x over x to the p power. And then we can just do a check real quick. If you plug in infinity into all these x, on the top, you are going to end up with ln infinity, which is infinity. And then on the bottom, you're going to get infinity to the p power, which is also infinity, where the p is greater than 0. So it's a positive value. Infinity to positive power has to be infinity. So this is the infinity over infinity situation. We can use L'Hopital's rule to help us out. So this right here is going to be the same as by L'Hopital's rule. What we can do is, this is going to be the limit as x goes to infinity. And then L'Hopital's rule says, I don't want to look at the functions. I want to compare their derivatives. On the numerator, we have ln x. Let me just differentiate that by itself. So this is not a quotient rule. I'm looking at ln x and then differentiate that, which is going to be 1 over x over. And then we'll look at the denominator, which is x to the p power, and then also differentiate that by itself. And since this is x to some power, how do I take the derivative of that? Take the power to the front and then minus 1. So we have what? P times x to the p minus 1 power. And then we are going to check the limit right here. Well, this is 1 over x. Let me just multiply by x here because it's like a complex fractions. This way, the x and x will cancel. And all we are going to get is, this is the limit. As x goes to infinity, I'll just have 1 on the top. And then here we have an x on the denominator, like the red one right here. The p is just the p, times x to the p minus 1 power times x to the first power right here. It's kind of like the first power. We can add the exponents together, and we get x to the p power. And in fact, I don't need to do too much fancy things for this, because I can just plug in infinity right here, and then once again, p is a positive power, right? So we are just going to end up with 1 over positive value for p, and then we have infinity raised to the positive power, and then this right here, we know this is the same as 1 over infinity, which we get 0. In another word, whenever you have ln x on the top over x to some power, where power is a positive power, you're always going to get 0 for that. And then this will show you ln x is growing slower compared to x to some power.